start. For people who watched or were attending the last session, is there anything that you wanted to sort of mention, ask questions about? And this is mainly the reason I ask people to come here instead of just watching it on YouTube, because it's more interactive, so people can actually just jump in if there's anything that they want to ask. So I'm just wondering if there's anything specific that you guys saw that didn't make sense to you guys, or like you want to see again, anything like that. Good? Okay. So this session, I'm hoping to actually make this a little bit more interactive. So I want people to sort of give me ideas. And this is basically the whole point of doing legal data science, because you're going to have a whole bunch of data that if I give data to the data scientists, they're not going to know what to do with it, right? Because we could have the data, but knowing what exactly is useful in this data is anyone's guess, which I'll show you towards the end. So once you download that file, which we're going to be going through, you're going to see what I mean when I tell you that we have to actually talk about this. With that being said, I just want to do a quick recap of what we did last time. So basically, very basically, we talked about variables and like the types of variables that we have. So just calling anything, let's say, var1. And for people who don't know, that's basically equivalent to the equal sign and basically any other coding language. And R, it just happens that they use that one. If you do use any other coding language, feel free to use equals. It does pretty much the same thing for your purpose. So it's whatever you're more comfortable with. I tend to go with equal sign, but it looks like R really wants you to do this. So if you see me going back to equal sign, just know that they're equivalent. So we said we had numeric variables like var1, and if you want to execute this line, would be in your Windows is going to be Control Enter, or it's going to be Command Enter in Mac, and that's how you execute a specific line in R. With that being said, Steve. Hello.
Hi, is this a launch?
Yes. Feel free to take some food and you can join. So this is how you execute the line in R. And then we had characters. So like if I call the second variable var2 and I call it, let's say hello, and I have to put it in quotation marks, that's how you tell R that this is actually a character that I'm putting there, and then execute again. As you can see, this is where you run the code. So over here, I said var1 is 1, var2 is hello. And we also had some logical variables where we talk about that they could be true or false, given any basically of the logical operators that we talked about last time. So like we want to say if it's equals or it's not equal to, they're less than or more, something like that. Is there any questions regarding these like variables and logical operators or anything like that? Do you want me to go through them again? Do you feel comfortable?
Everyone following along?
Good. So far, so good. Then we talked about vectors. So we said vectors are basically variables that are put in a certain sequence. And that's how we basically call them. And it could be anything. So let's say if we have vector 1, and the way we put vectors in R is by putting the word C, and then in parentheses, we define what the vector is. So for example, our first vector could be 1, 2, 3, 4, 5. This could be our vector, or our vector could be vec2 could be A, B, C. And again, you're going to see basically these are the elements on your vector. So basically, you're going to get a vector, and there are these elements in it, and you don't have to have the same type of variable in the vectors. You can have a numeric, basically a true or false, so logical, or you can have character, it doesn't matter. So you can have it all in the same sort of vector. With that being said, then we talked about how we can access these vectors. So basically, if we had a vector 1, does anybody remember how we put numbers in a sequence with what function? So if I wanted to get a sequence of numbers, let's say from 1 to 20, and I wanted to just put it there. It's okay if you don't remember, I'm just trying to see if this is gonna be like, I told you, like learning a new language. You're gonna have to repeat this so many times until it just like comes to you. So I just wanna know if anybody remembers. Yes. Great, thank you. SEQ, and then the first number is where you wanna start. The second number is where you wanna end, let's say to 20. And the third is optional and it gives you the steps in which you want to count the numbers. So if I want to say, for example, give me the numbers between 1 to 20 in steps of 2, right? So when I do that, if I say vec, I named it vec1, it doesn't matter, it overrides. So if I say vec1 and I want to see what it looks like, it will be 1, 3, 5, 7, 9, 13, 15, 17, 19. So basically that's what you get. So now you have a vector and you have certain elements. These are the elements of each vector. So the first element, the second element, the third element, the fourth element, and so on. If you want to access any of those elements, all you have to do is say vec1, and in these little things, I don't know, I keep forgetting. And there you put the element or the elements that you want to get from this vector. So let's say if I wanted to get the second element. So what I'm telling R to do is give me from vector 1 the second element, and that will be 3, as you can see over here. That's our second element, right? And we also talked about how we can actually see which element corresponds to a certain value in our vector by using the function which. Oops. So we said which vec1 equals, and this is the logical equal that we talked about. So not actual equals. So this is logical equals 3. What this gives R is which element number corresponds to the value of 3. And if you do that, you should get 2. That means the second element in that vector corresponds to that value. It works with all elements. So like our vector 2 is, as you can see over here, A, B, C. So if I say which element of vector 2 corresponds to A, I get the 1. So that means the first element corresponds to A. So far so good? Good, okay, perfect. And then we have, we can get a range of elements. So we can say, I want, let's say the second item, the third item, and the 10th item of vector 1. And I have to give a vector with the number of elements, the elements that I want R to show me. So if I give it a vector of, let's say I want the second element, the fourth element, and let's say 8th element, right? So what this tells R is, okay, give me from vector 1, the second element, the fourth element, and the 8th element. And if you execute that, then you get 3, 7, and 15. That means it's basically the elements that are, the second, fourth, and 8th. And then you can do logical operations with this one. So give me vector 1, for example. I want the variables that are only the ones that are greater than, let's say, 9. How would you do that? Does anybody remember? If I want to say R, give me something in vector 1, but give me only the elements that are larger than 9. it would be, so you're saying, okay, from vector 1, give me the elements where vector 1 is larger than 9. These are the elements that you get in that vector. So 11, 13, 15, 17, 19. Okay? And this, don't forget, when you're doing this, you get the actual elements. Okay? When you do which, it gives you the number of elements, so the number in which that element is. So if I were to say, for example, which, where is it? Vector 1 is larger than 9. I'm gonna get 6, 7, 8, 9, 10. So that means the 6, 7, 8, 9, and 10th element are larger than 9. And those elements, so if I put this 6, 7, 8, 9, 10, so if I say, okay, fine, give me the values of those. If I say, give me the values of 6, 7, 8, 9, and 10, you should hopefully see the same result that you see over there. Is the difference clear? Does everybody get what the which function is doing and what we're getting over here? Is there any like confusion going on? We're good? Okay, perfect. So that's that. And I think this was pretty much a recap. So if you know this by now, and if you know how to sort of manipulate the vectors and how to get access to them, data frames become very, very easy. So basically, once we move one step further, and let's go to, we're going to call it data frames. So what are data frames, basically? Data frames are sort of like your typical Excel file. So you're going to have some rows, some columns, and there's going to be data in them. And we just happen to call them data frames in R. The way it works is basically R recognizes each vector once you put them in basically R as a column of a data frame. Okay, so basically if I wanted to create a data frame, let's say of a few vectors, let's just create some vectors first. Who wants to give me some vectors? Give me a vector that has 5 variables in it, just anything. You can talk, it's okay, it's not a thing. So just anything, any vector that has any variables in them. Could be numbers, could be characters, anything you want. Yeah. 1, 2. So 1, 2, 3. Is that what you said?
Yeah, that's fine.
Okay, and we can do, let's go up to 5. So 4 and 5. Okay, that would be our first vector. Let's go for a second vector. A, B, C, D. Okay, let's go. A, B, C, D, and E. Okay, and a third vector.
Yeah, any numbers?
Any number, any word, anything you want it to be. It has to be 5 elements.
900.
Okay, but like just give me 5 elements. So like anything you want. So 900, for example.
Yeah,
Okay.
100,000 and 3.
3.
Yeah, and like 420.
420?
Yeah.
Okay. Okay, sure. And one more.
And yeah.
Okay.
That's like that. There we go.
There we go. Okay, and that's our third vector. Okay, so if I want to make this into a data frame, and what I'm talking about is, hopefully you guys can see it over here when I write. Can people see over here when I'm writing? Yeah. So what I'm trying to do is, if I have, let's say, think of it as an Excel file with rows and columns, right? So what I'm going to do, if I put those vectors, each of those vectors are going to be recognized as a column. So what we're trying to create is that first vector will go in like this, the 5 elements. The second vector will go in like this, and then the third like this. So that's how we're trying to create the Excel file. Does that make sense? Okay, so with that being said, so if I wanted to do that, all I have to do is, let's call it df as in data frame. Okay, that equals data dot frame. So that's basically the function that you're going to be using to create a data frame. Data dot frame. Okay, you put all the vectors back to back over there. So you say vec1, vec2, and vec3. Okay, so if I do this and I run this, it's going to save df as a data frame. You still can't see it because I haven't printed it yet. Okay, so now if I were to just put df over here and I make this a bit larger, this is what we've created in the data frame. So 1, 2, 3, 4, 5, that's the first vector. A, B, C, D, E, second vector, and 900, 1,000, 3, 420, and hello as your third column. Okay, so this is how you create a data frame. Usually, if it's a small data frame, you can look at it this way, so you can put it here. I don't like looking at it this way because it gets a little complicated. So what I usually do is there's this function called view with capital V. Okay, so view, and then if you put view df instead of printing it, then you're going to get it in a separate file and you're going to basically be able to do it over here. And you're going to see it over here. Okay, so, and that's what we basically now we've come up with. Okay, so that's our data frame. Now there's a few things that you have to know about data frames. So data frames in R have rows and columns are identified by rows and columns. So if you want to, let's say, access a certain thing, you have to call R and say that give me the second row and let's say the second column. And that's what's gonna basically end up appearing here. So you guys remember when we were creating vectors, we were only giving one value to basically see which element we want. For the data frames, what we're going to do is we're actually going to give them 2 values, one corresponding to the rows, the second corresponding to the columns. Okay, I'm going to get to that in just a second, but before that, I want to give you just a few things if you want to change something about your data frame or something like that. Some useful functions I will just put over here. Okay, so first of all is the call names. As a call names function, that gives you the name of the columns in your data. Okay, so if I say call names df, I'm asking R to give me basically the names of the columns that I have for my data frame. So vec1, vec2, vec3 are basically the name of the columns. Okay, you can do the same thing with row names. So row names df, row names df, then these are the name of the rows that you have, 1, 2, 3, 4, 5 going on. Do you guys remember how we measured how many elements are in a vector? Does anybody remember? Yes, that's right. Right. Good job, Kevin. Length. That worked for like vec1, for example. That was a vector, right? But if I use length over here for a data frame, length in the data frame is only going to count the number of columns, not the rows, nothing else. So what you're seeing with over here is only going to be the length, as in the number of columns that are in R, which could be useful if you want. But if you want to know how many rows and how many columns you have in a certain data frame, the options, so number of rows and columns. So the functions are n row. Okay, and I put n row df. Gonna give me 5. So that's gonna be basically the total number of rows you have in a data frame. And then you have n call. Very similar. Df, that's gonna do the same as length. It's just gonna give you the number of columns that you have. This is gonna become handy later on when you have like thousands and thousands of data points and you obviously don't want to open all of it and you just want to simply know how much data you're dealing with or how much data. Yes.
For your data frame, do you have to have the same?
Usually that's the way it works. If you don't have it, R somehow manages to fill it up with either repetition. So like, for example, if a vector is one less than the other ones, it fills up like repeating the vectors, or it puts it as NA. So as in not available.
So the number of rows would just be.
Yes, so that would still be the longest one. So basically, if I were to delete this, I actually want to know what happens in the new version. So if I were to change that, and if I were to do this, oh, it actually gives you no. So it wouldn't give you. So back then, I used to just repeat or just put not available. But in the new version, it actually just tells you that the number of rows don't match, so you can't even put it there. Oh, hi.
Hello.
Hi, guys. Get your food and just sit. Yeah. No worries. So we just put that back and put it here. Okay. So now just very simple. Data frames like Excel files. Just think of them as Excel files. Okay. Any sort of information you want in it could be in it. So like whether it's numbers, whether it's characters, whether it's a logical operator, very, very useful. Obviously in any sort of legal data that you're going to be working with. Obviously we talked about this. Numbers correspond to, well, you're going to see in the file that I give you. So the year, for example, the number of judges that are sitting in a decision, the number of dissenters that are basically, you know, for each case. Then you have the characters, which is, for example, the name of the judges, or you have the form of, for example, case. Is it a written case or is it an oral case? Something like that. And then finally, you have you can have logical operator for people who use Python. That's Boolean. I think people sometimes get confused by that. It's just a true or false sort of thing. So there's just a binary decision of either true or false. And basically, you can have those values again. So you can put it as, is it criminal, true or false, or is it constitutional, true or false, something like that. And you create those data, right? So now let's try to work with a smaller data frame than the one that I'm going to give you, because we're going to jump onto that. And I want everybody to sort of try to figure this out while we're doing this. I want you to basically pull up this data. This is actually the type of data that's available in R, so you actually don't have to do much about it. So what I want you to write is call anything you want. So df2, right? That's data frame 2. And I want you to get US arrests like that. And that should be available in R. It's actually something that's available. And I want you to execute that. Is there anybody who did not manage to get that? Okay, so what I'm going to do now, I'm going to view df2. And this is basically what you're dealing with. This data shows the murder rate, the assault rate, the urban population, and the rape cases. Basically, I think the numbers represent 1 in 10,000 for each state in the US. And I think this data is from 2018. I'm not sure, but this is the data you're dealing with. Okay. What I want you to do is, this is for your own sake, because sometimes when you basically bring in data from other places. It looks like it's like a data frame, but sometimes it's not. Just for your own sake, usually make sure you run this line, and you want to say your df2 is as data frame df2. So you're saying, give me df2, but give it to me as a data frame. That's the function you're going to be using to get everything in data frame. Because sometimes you have matrices, which are very, very similar to data frames, but in some cases they'll make you like, it's going to cause an error somewhere. So make sure whenever you're importing any sort of data, make sure you put this function and just say, give df2 to me as a data frame. Okay, so that makes sure that what you're getting there is a data frame. Okay, so now let's go back to this. So we have, let's view df2. Okay, so what do we see over here? So this specific data frame is basically numbers only, right? So we just have numbers over here. And what I want you to see is how we can access data in a certain data frame, and how we access just one or several elements of a certain basically data frame. Let's start with, let's see. So if I wanted to just access one element, everybody still familiar with the hashtag one, right? That's just for using comments. Do it all the time. You're going to get confused. Trust me, these are your friends. I used to write, when I started sort of off topic, but I used to write my code without putting any of these comments anywhere in my line. And then by the time I was at like 10,000 lines of coding, I would want to go back and try to figure out what I did, and I couldn't, because there was just too much happening over there. I couldn't find it. So make sure you put those notes over there just for your own, like, sanity, I would say. So let's say you want to access the element. So what we did in the vectors, what we had was, I'm going to actually write df2. And we had just one element over here. We would say, give me the second element, or give me the 10th element, right? Now we have to specify what we want by rows and columns, because it's not just one sort of data that we're dealing with. So we're dealing with rows and columns. And the way we do it is, and I always do this, do it again, I'm telling you, when you want to access anything in the data frame, put a comma, and that comma separates the rows that you want first, comma, the columns that you want second. Okay, so if I, let's say, wanted to access this, let's say I want to see the assault rate in Alaska, and that's the second element on the second row and the second column. That's a little easy. Let's do the third row and the fourth column, which is the rape rate in Arizona, which is 31. Does everybody see it? So third row, fourth column. So what we want to do now is we want the third row, always remember, fourth column. So the first number that you're going to be putting here represents the rows. The second one that you're going to be putting is the columns, okay? And if you want to do that, it's going to give you the value over here. All that's saying is that in your data frame, the third row, fourth column is 31, okay? df2, always remember, put the comma. What if I wanted an entire column, right? Or an entire row? Let's say I wanted the entire row, okay? What if in this data frame, I wanted the entire data, so murder, assault, urban population, or rape for Arkansas, right? Arkansas is number 4. I can say, give me the 4th row. For columns, I'll just leave it empty. What that tells R is that I want all the columns, okay? So what that will do is it will give you all the columns. And basically for that specific row. Can you take a guess of how we do this if we want all the columns, but just. I mean, all the rows, but just one column? The opposite, like, I want now all the rows. Which is like, I want all the murder rates. For all the, basically rows. That's our first column, right? So we don't have a problem with that, we know it's the first column. Right, yes,
In data frames like these, the header column will be excluded automatically.
in this one it is, yeah, so that one also, so that's a good question. So what I'm gonna show you is, I'm gonna write. Call names, which is what we did to see the column names, the names of the columns for DF2. And if I do this. You're gonna see that it's gonna tell me that these are the name of the column, so they're not part of the data. Does that make sense?
Yeah, so if I just want to call a particular row, I can just do call names for subsequent rows as well.
What exactly, so,
In order to call a particular row,
okay,
can I use call names like here, the first header row has come?
yeah. I mean, we can try it. Let's see, so you want. We're jumping a little ahead, but let's say you want the third row. And you want the call names. Of DF2. Right, so it's still gonna give you that. It's a little redundant in the sense that this, if you do it like this, you'll only get all the columns, which you might as well just leave empty. Right, so you're just doing more work, but obviously it is possible. It's still telling R to do the same thing. As mentioned again, there's not one way to do it. Yeah.
Data frame could I transpose rows?
Yes, yeah, you can do that. I'll show you how to do that, but I'm gonna do it after class because I think it's gonna get a little confusing for people if they want to transpose, but it's definitely possible. It's just one function that you use and you just transpose it. Okay, you can even pivot tables if you want to within R. Yes,
We have a big data set, and you don't know which, like row is which, can you use the name of the row, like text C or text C?
yeah, I'll show you, yeah. Jumping ahead, but that's good, I like it. So let's say, yeah, so let's try this one. So if you want, let's say all the rows with one specific column, DF2. And you want all the rows, so I'm gonna leave it empty. Right? And I want the first column, which is the assault, right? What it's gonna give me is, and I wanna show you this because now what you're getting is actually a vector of all the numbers 13.2, 10, 8.1, which is, as you can see over here, 13.2, 10, 8.1 going forward, and you see it as a vector over here. The reason you're seeing it as a vector is, again, I told you, R stores these data frames with keeping in mind that columns are actually vectors. So if you call any specific column in R, it's gonna return a vector. It's gonna be very important for you when you start using for loops and all that. So keep that in mind because you're gonna get a vector once you, I can literally do this. So like, if you keep this in mind, so now I told you, when you execute this, this is a vector, right? And remember how we used to be able to call upon elements in the vector, right? So if I wanted, let's say the third element of this vector, all I can do is just literally add that over here on top of that, number 3, and I would get 8.1. Do you see what I mean? So like just a side thing. So don't worry about it, but I just wanted to say that if you call all the columns, that's how you're gonna do it, okay? So now let's get to, yes, if you wanted to put all the, you don't know. So it's gonna be, for example, in data frames like this, and you obviously cannot know, for example, which number Kentucky is, right? So what you can do is give me, let's say, tell R to give me the Kentucky row. Did I write it? I think I did. All right. And give me all the columns. All right. Did I not write it right?
Yeah, too. Should be DF2, just right.
Oh, sorry. Yes, my bad. You're right. There we go. All R is gonna recognize that you want this row, because that's the name of the row over there, right? And if I put row names, did I put row names? I didn't. So if I put row names over here, row names, df2. Sorry, my keyboard is awful. You're gonna see the name of the row. So these are the name of the rows. Okay, so you can still do this like this. So if you wanted a Kentucky and you wanted only the salt column, you can even call the columns like this. So you can say, give me Kentucky and give me the one that's assault, which is over here. So Kentucky, and then the assault is the second one, which is 109, and that's what you get over here. You see, so it's easy to sort of try to figure out which element you want to work with, but obviously we can make it easier. Let's say if you wanted to get all the elements in a certain column, all right? And I mentioned this, I cannot stress this enough, this is gonna be a vector. Okay, if you call up columns, you're gonna get a vector. If you call the rows, you're not gonna get a vector. So if I wanted to call, let's say, all the numbers, all the elements of the assault for all the basically states that you see over here, instead of saying, oh, my here, sorry. Instead of saying df2, give me all the columns or give me that column, you can do this by calling the $sign. Okay. Once you put the $sign, it's going to show you all the columns that you have over here. Okay. Once you put the $sign, you can choose, let's say if I want the murder, assault, urban population, I'm going to say assault, enter. And if I do that, again, it's going to give me all the elements of that specific column, the assault column. So now you have a vector. Okay. So instead of me doing this, df2, give me all the rows and the assault, which is exactly the same thing, I can just call it like this. And this now becomes a vector on its own for which you can call up elements again. So I want to say, I want to get the 14th element of the assault, of the assault column. Okay. And if you do that, you get 113. Okay. So now keep in mind, this is a vector now. So you don't have to put a comma anymore because you're dealing with a vector. So with vectors, you just put 1. With your data set being like that is something comma. So rows, comma, columns. Make sense?
Something.
What is it?
Now I calculate something.
Yeah. So what exactly do you want to do? This is great because, well, we're going to do this obviously with the bigger data, but let's learn it here and then we can move to basically, the bigger data. So what exactly, which sum do you want to see, for example, here?
Just think so.
Assault. Okay, so let's do sum. I mean, in this case, mean would average would make more sense because you want to see the average assault rate. Just so, but we can do sum as well. So like what I can do is the function for sum is sum. And then you can say I want df2 and I want the assault one, right? So this is a vector now again. So the data frame to the assault column is a vector. So if I do that, then I'm getting the sum of all the values that are there over here, right? And I can do the same thing with mean. So if I just say mean instead of sum, it tells me the average assault rate in all the US states. Okay. So that's that. What if we wanted to get, yes, sorry, go ahead.
Just wanted to
Yes.
ask, which states would have more than one somebody assault?
Great, that's exactly what I was going to do now. So now let's go back to our DF2. Remember, DF2 is where we're working, right? So, and I always do this because once you do this, you know where you're going to put. So all you need to put is the rows and also the columns. Okay. so now let's see, so what exactly we want the rows to be, which rows do we want? Which one did you say, sorry?
Which states has over 170 salt?
Assault, okay, so you want the states where DF2 assault, right, is more than, what was that, 170? Okay, and you want all the columns? Okay. Once we do that, and I'm gonna put this in view so it looks better. You're gonna get all the states that have a assault value of more than 175 over here. Okay? I could have gone further. I would say, okay, I only want to see their murder rate. Okay? So put murder over here. Well, if I put murder, it's gonna, I should actually, you know what, let me do it like this so it doesn't get murder. And let's see. Now, okay, so I want the murder and the rape ones. I don't want all of them. I just want to know these values for the assault. So you see, assault is not even here, so we don't even care. All we want is if the assault is more than 175, tell me what the murder and the rape values are. Alicia,
What if you just want us to return the row names and any other data?
you just put row names. So like, basically, the way I would do it is, again, row names, EF2. And that would give you all the names of the rows. Okay, so that was good. So that was a conditional one, okay? So let's do a little bit more of these conditional ones and sort of play with it so we get comfortable with doing all these things. So let's do, again, I'm gonna put it in view because it just looks easier. Up to you. So DF, let's go. Let's look at our data. So what could be of interest over here for us? I want to do multiple logical operators over here. I want R to give me the rows where murder is more than, let's say, 8. And I also want assault being more than 200. Okay, so it's not just one, but it's both of them. So now I'm saying it's an AND operator. So keep that in mind. So it's going to be, this has to be satisfied and this has to be satisfied. So basically, I'm saying that I want DF2 murder being more than, what did we say, 8? Okay. Yeah, let's say 8. And it's not double AND, or again, I think in Python is double AND. I haven't used Python in like a year now, so I don't remember anybody who uses Python. Is it double AND or AND?
It's just the word and.
Right, yes, okay, perfect. Yes, so and I want DF to assault to also be more than 200. Okay? If I do that, oops. Did I put DF again? Yeah. Okay, there we go. There we go. So now I'm only getting the data where my murder rate is more than 8 and my assault is more than 200. So that's how you fine tune your data. Okay, so does that make sense to everybody now? Perfect. So now we can actually go ahead and download the data. Did Sabrina tell you how to download the data? First of all, what is it?
I told them where to go.
Okay, okay. So just go to our website over here. So it's going to be lit-group.ca/session2. Okay, in there, you're gonna see something that says materials. Sorry, materials for the second session. Okay, and I want you to download the data that you have over there. It's an RDS file. RDS is just an extension that says that this is an R file.
But in the Google Drive. First,
Take your time, like, this is my masterpiece, by the way. So just so you know, I wasted a whole year of my life creating this data. So it might seem simple to you guys, but just so you know, a lot of coding hours have gone into this. I cannot show you the full data because I feel like I wouldn't be allowed. This is the data from Supreme Court of Canada cases going from the year 2000 and up. And it's some of the data that basically has been collected about these cases. So basically, you know, who the judges are, who the dissenting judges are, the year, the citation, the way the decision was delivered, the appeal outcome, what else you'll see. But this is basically what we're going to be working with. And yeah, it's going to be fun. Okay, so has everybody been able to download the file? Are we ready to move on? Okay, perfect. I'm going to show you two ways of importing that data in your computer. If the first way doesn't work, then we'll go to the second one. I just want to make sure that, you know, so I'm going to call this data frame SCC, okay? The way you will call up this file is you write file dot choose. And it's going to have two parentheses like that. Okay, once you do that and you execute that, it's going to open up the file so you can actually see all your data, right? And I want you to find your data and I want you to open it in R. Is everybody able to do this? Actually, is anybody not able to do this? I think that's easier. So we're good? Everybody managed to get it? Okay, perfect. That's it. That's an easy way of actually selecting you know, stuff from R. People who are R professionals don't really like this because there's working directories and they usually tell you to just get the stuff from a working directory. Don't worry about it because you don't have to. So now I need to convert this RDS file to something that we can see over here. So I'm going to say SCC equals, and the function for that is read RDS, okay, SCC, the one that I just basically created. So now the data that I have is read into R. That's how you import files from R. And as I mentioned before, I'm going to make sure that this is imported as a data frame because I don't want any funny business. So far, so good? Everybody following? I feel like I have to ask the negative one. Anybody not following? Okay, perfect. So let's now view this beautiful data frame. Okay, do you guys see this? Is everybody able to see it? So in this file, you're going to see cases, their citation, the year they were decided, title. This is the number of characters in each case. This just tells you how many in the sort of is, you know, used to measure the length of each case, but that's a number of characters that are basically you're counting. You know how you have character count in Microsoft Word? It's basically that. where the appeal is coming from, the way the decision was delivered, who wrote the majority decision, the outcome of the appeal. This is the citation again. Going here, you're gonna see the number of judges who sat on the bench for that case, who the Chief Justice was, how many dissenters we had, and the number of authors, so how many people actually wrote in that decision, and the number of dissenters, each decision. Impressed so far? Okay, good. Okay, so now this is what you're realistically gonna be using in data analytics. So this is what you're gonna be mostly dealing with, this sort of information. There's all kinds of information over here. There is the numbers, there is the case, there is, obviously everything in there. So if once we get into plotting, hopefully next year, so next semester, you're gonna see what I mean when I say this is gonna be how you basically are gonna be accessing data. Just so you know, so for next semester, we're gonna be learning how to get this information from the case. So that's one thing. So how did I get Cote over here? That's like, I didn't just go through like 2,000 cases and just like, oh, this says Cote, this says, thing. So that wasn't the case. And also obviously how to plot data. With that being said, this is where this is what I meant when I said there's going to be data that if I just give to data scientists, they're not going to know what to do with. Okay, so right now I have this data. I don't know what I can do with this data, and I'll tell you, I've done a bunch with it. I've done the dissent rate for each year. I've done the dissent rate per chief justices. I've done what else have I done? I've done the appeals. So like, how many appeals come from each province and all that. I want you to take a look at this data. And now we're going to be trying to access data within this data frame. Okay. And I want you to take a look at it. And I want you to come up with something that you want to get from this case, from this data. And tell me, and hopefully tell me how you think we should be able to get that data. Take a look at it. I'm going to wait. Anything that there is over here with respect to the year, the character count, the appeal jurisdiction, the delivery method, the majority author, anything like that, and something that you want to know. So like how many cases were decided in 2021, for example, something like that. Does that make sense? This is where we need the lawyer mind and a little bit of thinking to see how this is going to be useful. So we have about 15 minutes, I want to say. So let's try to do at least like 4 or 5 of these data sort of, let's call it analytics for now. Yeah.
So I'm able to download the second session file.
Okay. The second session, I don't think you need to download that. You just need to download the RDS file. Did you download that one? Thanks, Lucia. Okay, so tell me, what do you want to know about all this data? As a lawyer, what is interesting to you?
In my own view, I feel like as lawyers, like first of all, we do like a lot of like legal research.
Mhm.
So if I'm preparing a case,
Mhm.
like for one of these judges, so I'll probably try to find out maybe how many cases dealing with child abuse
Mhm.
have been dismissed by Supreme Court, like by a specific judge. So, but I don't see the data you have here does not talk about certain areas of law that we like handle in these.
Yeah, Yes, I cannot show you because this data is still not published. So the areas, there's a bunch of columns that I had to basically take out from here. One of them was the areas of law, basically, which I am not allowed to show you. I mean, yes, this is gonna be useful. Hopefully by the time it gets published, I can. But just out of this, so like, let's say you have this data, and if there's something interesting to you in terms of the number of dissenters, the number of judges, the case, I mean, the year, or, you know, the jurisdiction.
Maybe
If you-
I would say, the dismissal rate of like Abdella J, because I've come across some of these, decisions, so I could say dismissal rate or like the amount or the number of dismissals. Abdella J has, provided between maybe 2000 and I don't see any dates.
No, you can, and
2001, maybe.
okay, when you say Abella, what exactly?
Abdella is the name of the justice.
No, I do, like, I know, but so you're saying the ones that basically Justice Abella authored?
Decided, yes.
Okay, so you want to say,
The number of dismissals.
that's good, okay, so it gets a little bit more into the professional realm, but let's do it. I'm sure we can do it, but tell me, so, okay, you told me that, right? So now we want to convert that into computer language, and we want to tell R, give me the data where the majority author is Justice Abella and the appeal decision is appeal dismissed. Okay, so how would you go about doing that? I'm gonna write SCC and this is our data, and I'm gonna put the comma over there. We're gonna assume that you want all the columns, so let's work with that one. And I'm gonna put this in view, so again, it makes it a little easier. Okay, so which rows do we want? Let's think about it. So like now, look at the data, okay? So let's start by seeing what are the cases that majority author is just Justice Abella. Okay, let's start by doing that. So how do we go about doing that? I would say the rows that I want in SCC are where SCC's majority author, right? This is gonna be a logical value, right? Equals, so double equals Abella. Okay, we want all the columns. If I were to run this, it's gonna give me all the cases where the author is Justice Abella. Okay, so now we have this data and we can see that there are cases, for example, in 2021 and 2020 and 2018, all that, right? So we've filtered the first part a little. So now we only have the ones that Justice Abella decided. Okay, which is about, geez. Okay, yeah, that's a lot. Okay. Now you want to look at the appeal outcome. You want to see how many cases that Justice Abella wrote, the case was dismissed, right? So we further filter our data based on that, right? So now I come over here and I say, give me the ones where the majority author is Abella, and yeah, go ahead. Try it, it's okay. Does anybody want to try? Yeah, so like you're gonna have to call that specific column, right? So you want to call the appeal outcome column, and you want to say that I want that to be appeal dismissed. Okay, so what you want to say is I want now in this one, the appeal outcome So SCC at appeal outcome, right? So this is your vector being equal to appeal dismissed, right? So now we put two conditions in that. And if we run that, now we only have cases where Justice Abdullah wrote the majority opinion. And in that decision, the appeal was dismissed. Okay? And then you obviously have all the other data that's available. So you might not be interested in obviously those two columns. You might want to just know the year, right? You just want to know, for example, how many was it in 2018? Something like that, right? So that's how you filter down the data that you want to access. Okay? Okay, let's do more. I want people to sort of understand how they can manipulate this data. So this is all our entire data. What would you like to know about this data? As lawyers, go ahead. Fair enough. So we're looking at cases where we had at least 4 dissenters. Sort of like we're looking at those cases, right? Okay. Do you want to suggest how we can go about doing that? I'm going to delete this part so we can. She's going to keep this because I'm going to post this in the script so people can use it later. But now let's delete this. So tell me, in terms of columns, what exactly are we looking for? No, and you just like try to think of it this way. That's what I'm saying. When you're coding, right? Say it in your own language, see what you want to do, and then try to convert that into what you want R to do. Okay, what exactly are you asking R here? You're asking where I want R to give me only the cases, only the rows that there's just the number, the set number over there is 4. I don't want 1, I don't want 0, I don't want anything else. I want only the cases where there's 4. What is it? That's right. Yeah, we can, well, that's right. So you can say, well, if you want to do that, you have to use a if conditional sentencing. So I'm not going to go into that, but let's assume that we want only the cases where, we assume that they're all 9 and we want 4 dissenters in them. Okay. We'll get into the if and for loop, hopefully, I think next week. So yes.
Can't you just ask it where the judge count is 9 and dissent is 4? Then print it that way.
You could, yeah, you could do that, yeah. Okay, yeah, let's do that. Okay, so SCC, we want SCC. What was it? We want the judge count to be equal to 9, right? And we want the SCC dissent number 4. Right? There we go. 2021, 2020, 2019. These are all the cases that you see over here, and you can see obviously the name of the case over here. Toronto and Ontario. I remember this case. And you can see that these are all 4, and then there was a full bench and 4 dissenters over there. Yes, Alexia.
Sorry, if you wanted to get close cases, but not just 9, if you did like where dissent is 1 greater than majority number, I guess you don't have a column for number of.
The majority?
Yeah.
No, we don't have that. Yeah.
Maybe we have to do that where it's like.
Oh, you do minus that? No, I intentionally didn't put it there because you can do it. I actually have it in the full Excel file, but and over here, I think you can still just say, okay, so 9 and 4, it makes sense. That just means that there's a 4 dissenters and a 9 person bench. That just gives you the maximum majority. Sorry, the minimum majority, the maximum dissenters, right? There was actually a case where there was I saw 5 over there. I can't I'm telling you. And then I thought there was a mistake in the code, but no, there was actually 5 dissenters. For some reason, I still can't figure it out how. I'll show you the case later. It's a very strange. One last one because we only have 2 minutes ago. Let's take one more. And let's try to get something. You want numbers, you want characters. That appeal jurisdiction, something that you're interested in knowing. Let's see how many cases came from Ontario. Right, we only want to get the cases that come from Ontario. Can somebody help me with writing this out? I'm gonna put this. Tell me what we want. Ontario, and we want all the columns? Why not? I mean, just to make it a little fun, why don't we just get the titles? Just to show you how you can actually do this. Oh, it's gonna be, I keep forgetting that's a vector, so how about, yeah, we do all of them first. It's gonna be all the cases that came from Ontario. Right? And all the information over there.
Always have to enter like one condition at a time.
No, you can do 10 conditions if you want to, you can with this and that, or this or that. If you want, so I want like Justice Abella or Justice Wagner. You know, you can do that. Or, you know, I want 2021 or 2020, doesn't matter. Right? So it works. So it's just conditional. And I think, well, there's a lot of obviously stuff to play over here. If you want to see like which cases are long, you can, you know, for example, say, okay, give me only the cases where the character number is more than like 200,000 or 100,000, or give me only the written reasons. Give me what? Give me only the full bench cases. So only the ones that have 9 judges. Something like that. There's a lot of stuff to play with, right? So I want you to just get comfortable playing with this stuff, because next week, not next week, geez, next time when we meet, we're gonna be doing plotting, and we're gonna be doing, well, some conditional sentences, which will make more sense. So the for loops and the ifs, the if statements or conditionals. But yeah, so this is pretty much, so I really want you to be comfortable playing with this data. So, you know, create Excel files for yourself if you want to. Try to manipulate the data, try to get it, make as many conditional sentences as you can, because this in reality is what you're going to be working with. So as a lawyer, if you want to end up in like legal data science, this is the sort of data that you're going to be eventually gathering together, which I'll show you how. And this is basically, this is going to be the end work sort of thing.
Sorry, it's a little bit like an unrelated question. So I'm like, I know this is the back office.
Mhm.
So now, like, how I would really like to see how users, like online users, can have access to all of this stuff, like the finished products
Mhm.
in a normal, on a normal like website.
Well, that's up to you, right? You can publish it as an Excel file, which is like what Lesner's Lab is doing right now. And Lesner's Lab, the law firm, they actually have the data that they gather, and they just put it in an Excel file and they just put it out there. They published it. You can put it on a website. You can use, if you're good with Microsoft, you can use, there's so many things you can use. Like just, you know, using plots and using, it's really up to you. So like if you want to plot it and put it there, if you want to just put the raw file over there, we get into that like later on. Just like there's a lot of forms of analytics that you can do with this sort of data. But I want you to be comfortable with trying to access the data, because that's going to be important, because you're never going to be working with the entire file. That's not going to happen. There's specific items in the file that you're going to be wanting to work on, and you need to be able to get them comfortable. Make
So
sense?
thank you guys all for coming
Of course.
to the second Lunch and Code event. Sorry we went a little bit over time. But just to let you guys know, we're going to be continuing holding these sort of events in the winter semester. So watch out for messages from us for another event, hopefully in January. On that note, we are running our final event of the year, our final event of the semester. It's not a lunch and code event, it's actually a debate on AI and the law. It's going to be moderated by Professor Niblett. And it's occurring, I think in this room, but I have to confirm next week during lunch, so 1 week from today. Where people will come in and we're going to ask questions like, should AI be a legal person? Will AI take our jobs? Things like that.
And it's not gonna be a lecture, just so you know, it's gonna be a debate, so you're gonna be,
You guys will be debating.
yes, you're gonna be talking, so that's gonna be,
And you'll be-
yes.
Thank you guys for coming. If you have other questions, Ari will be here at the front.
Yes.
And also you can reach out to us at lit-group.ca.
Yes.
Or you can also check out our website that has contact info. Thank you.
And I believe you still have about 10 minutes to go play with the puppies,
Yeah.
if you want to.
Okay.
That is, I think, it. Pretty much. Let's, oh,
Got it. Also, there's a lot of.
problem.
You guys are-
Let me know if you have any questions or something, just shoot me an email. Hi. All right. Nice to meet you.
I looked at the website. And the
Yes. Yes, yes, I actually saw one of the applications, and I think it came on Friday.
Yeah.
We're busy with so I'll definitely get back to you.
Yeah.
All right, we'll definitely be in touch. So I want to email you,
It'll be on
and
the.
then I can definitely be in touch. If you're interested.
Yeah, because you were a student, you work.
I'm a student here, so I'm a 3L here,
Okay.
and yeah, I used to do data science, just as a hobby, I guess, beforehand.
All right.
And, you know, I just came here and I'm like, okay, I'll like to keep doing this, so.
I'm also. There I even though I haven't done coding as such, but like my research was related to predictive analytics. So I thought that this is a good way to get in.
Definitely, yes, I mean, this is specifically for people who don't have it,
Yeah.
right? So that's what I'm trying to sort of encourage people to do, so like it's, you don't have to have to understand these. See you, thank you for coming. Yeah, you know, also like, I just want to encourage people to just come here and just learn. I know that it's not only for, you know, science, French, people from other backgrounds can and learn how to do this. I don't think you need a to do this.
Yeah. So I'm not in the role field, so I'm sure like the coming events and if you want to talk to this.
See, drop by, of course, we're open to the public, so. Yes, we have, I think 4 or 5 students coming from Osgood.
Yeah.
Yeah, I know, so like we have 4 or 5 students coming from Osgood. Just a little far from them today, I think, for to watch the video, but yeah, so we actually have.
Nice.
See you around. How you doing, man? How are you? How's it going?
It's not pencils.
Okay.
It's not actually though.
Okay, that's fine.
I was the other person by the
Okay. Yeah, I think so. We're looking for, because most of them are gonna be like, you know,
Yeah,
second
it's
semester, we
exciting.
still have
A lot of
like,
questions. It's just
quite a
trying
bit of a
to-
time to be able to like sort of talk to them. Yeah, so don't worry about it, it's good. I think it's like, the first one, so we get the rest of it. Yeah, so these ones, the supporting events, it's gonna be like. Sort of stuff. But yeah. Anything.
I was wondering about the dates.
Oh, no.
Always give us like the data.
That's, yeah, I'm gonna hopefully try and teach you how to do that in the second semester.
Yeah.
That's something called national language. So I'm waiting on you. We're gonna get the raw data. You're gonna be able to implement all of these things that you.
Any informal thing that was.
Say, okay, if you detect, for example, a specific word, this is what I want you to do. Right? How do you do it? Well, you can.
You don't have to, you're gonna have.
Mostly over here though, and like you can, for example,
Have your
I got,
But that session will
like
not be.
centers, for example, it's every page you always have on the top, where it says health, and in parentheses.
For your
it
this.
says blah, blah, blah. So you go and like, if you check this part, this specific part, that's the name of the center.
Yeah.
And that's how you get it.
Yeah, sounds pretty advanced.
Yeah, it's not, honestly, it's not. You can learn how to do it, and again, I don't think you need a science background.
Yeah.
It's, well,
Maybe a little, but I would honestly, I wouldn't worry about it if anyone.
AI.
Do not think it's gonna be.
Agree that we're in their hand, okay, you agree, plain line, you agree, plain line.
But
Right,
I should probably say.
No, it was fine for me. 'cause like-
We need to follow.
Yeah, yeah, like.
He does AI involved.
It's-
So he's.
It's not too hard.